In this video, we will discuss more about the big picture of the object-oriented programming. There is a nice diagram that we might call it the OO diagram. It consists of, as you see, 4 levels, something called the OO paradigm, and this is explaining what OOB is about. And then OO concepts, and this is typically the core of any OOB programming concepts. There are like 6 fundamental concepts in programming. There are also the object-oriented principles, some principles that are very important to make your code much better. They are typically not explained in OOB courses, but I'm going to highlight them in a specific way. There are also design patterns that also like part of the big OOB picture. So the whole OOB paradigm is about making the objects as a very centralized concept in the whole project. You suppose at this moment of time with the projects that we did using the struct, you already created a lot of object of hospital, object for a library, object for a user, object for a question and answer, and so on. OOB is all about making these objects as a very centralized way to the projects. But OOB involve a lot of things that would make the design is much fit with real life needs. The OOB is a paradigm. The word paradigm or programming paradigm means a way of thinking, viewing, structuring your software. So it is like a philosophy of something. OOB is just one of them. Before that, there are many other paradigms like declarative, functional. One of the very popular way is the procedural programming. This is what we actually were doing early in C++, introducing functions and so on. So this is one of the old paradigms. So why OOB? Why is it important? If you try to thought about the classes that we were doing, structs specifically, we noticed some correspondence between real-world objects and OOB classes. So the way that you interpret your own project, like say I'm doing a project to implement an ATM machine, you notice there are some correspondence between what we have in reality and what we have in our classes or our structs. Every time I mention class, I just mean struct, if the word class is still not familiar for you. OOB help us a lot to handle the complexity of software products. There is what we call software crisis. A lot of softwares might be over budget, might be over time, delivered with a lot of buggy functionalities, or even functionalities that doesn't meet requirement, or even never delivered. So this is what we call software crisis, and OOB help us to some extent to handle that issue. OOB is just one paradigm, so there are 2 types of other people. There are a lot. OOB is the mandatory way of programming so far in the market, but still some people hate it and criticize it a lot. Some people think that the current designs are a bit not like doesn't match with the old intention for OOB, and so on. This is a future link to read it. Okay, so why did we stop procedural? Because of disadvantages of OOB, and because procedural lack a lot of issues, like for example, no owner of data, a lot of issues about comes to integrity of data. If there is a bug, it might be very hard to identify where is the bug and to debug your code. So I mentioned before the OOB concepts. We already know what is object and what is class. We highlighted what is encapsulation. In the next videos, we will first dig more. We will know about what is abstraction. Then we will go in one big round to know what is a class, like more of the class features in C++, for example. Then we will know what is this inheritance and what is this polymorphism. This is what typically an OOB course would do to explain these programming concepts. The principles, which is something that typically not taught in OOB concepts, is actually the most important thing in designing good softwares. These principles make your code like a much better one. An example of the principles, like solid principle, a single responsibility principle, for example, tell you something like your class should have one single reason for a change. It should be responsible for only one reason, one concern. This makes us, when we are developing classes, we don't make like a mega class containing every functionality and every variable. No, it be very specific, like this class for a user, this class for a question, and so on. the open closed principle. Your classes shouldn't be modifiable, but should allow people to extend them to add more functionalities, and so on. There are further concepts like dry, don't repeat yourself. Some people would do a lot of copy paste inside their code. This is wrong. Yes, keep it simple. A lot of people would complicate things. How to make things easier? Yagni. Sometimes people would add a lot of functionalities and they claim that in the far future we are going to use them, but they never use them. Okay, so one of the unique features in this course is the following. In a lot of homework, I embed in an implicit way these principles. So you're actually solving a homework that is actually a practice on one of these principles, and this is how I'm going in an implicit way teach you some of these principles. The design pattern is also one of the important things in software engineering. The idea is simple as there are a lot of repetitive design subtasks that we all face in reality. Remember the queue? The queue is something that we all meet. It doesn't make sense that we ask people to implement it all the time. In a similar way, the design of some functionality might be a repetitive task. So some people would gather together and tell us, you know what, this is one of the best ways to solve this problem. Okay, I would like you to warn you here from something. In a lot of CS curriculum, they might be stressing the design pattern in a way that students think that it's a way of life. It is a skill to know when to use design pattern and how to use them. It isn't about let's create like tons of design patterns in a project. It's actually the project decides what it needs. Sometimes some of the patterns are very common, like single and factor design pattern, factory not factor, and also others are less important. From a domain to another, some patterns might be used much more than others. Also, again, one of the unique things in this course, I embed some of this design pattern in the homework. The homework of the OOB is very critical, so don't skip any of it. Okay. After that, when it comes to studying design principles and design patterns, you will find them very intuitive because you already know about them and know context for them. There are three relevant terms: object-oriented analysis, object-oriented design, object-oriented programming. Object-oriented analysis is a step that happens in industry when we would like to analyze some requirements that we take from the customers, and then we start to think on things in terms of objects. And this typically involve a lot of things, and they are usually technology independent, just more of thought levels. Then there is something called object-oriented design, and this is where in reality we started to take care of a lot of important issues, like what kind of hardware and software we have. There's something called the availability of the system. When you are using your Facebook, you find it available all the time, right? The scalability. Facebook, for example, and Google, they handle millions or milliards of users. How, to what degree your software is going to be scalable? What kind of budget is our target? Designing a software design is an important skill that you take time to learn how to design good systems. One of the very important things in this course is the design skills. Again, through the homework, a lot of homework will stress a lot of design notes in a very, very useful way for you. If we are done with the object-oriented analysis and the object-oriented design, the next step is the object-oriented programming. This is actually what you usually are taught in programming courses, the syntax of a specific language so that you convert a design to an implementation. We are going definitely to make this is our focus here, the object-oriented programming. We are also going to highlight enough design notes during the homework so that you know how to design your systems. Also, one of the good ways to enforce the design is actually the projects. So there are also a few projects to help you doing that. Okay, so in reality, the company culture, the scale of the project, the team side decides how the three are applied. So let's say that you are working on a small project. To some extent, all of these concepts might be applied by a small team in a very unified way. So no one has this extension of, okay, these are the analysis step, this is a design step, this is a programming step. It doesn't go like that. And this actually happens in the market a lot. Like the same programmer is doing the design and programming by itself. And this is actually what happened in this course. The requirements are simple enough, we doesn't need analysis. Then you do design and you do programming. In larger projects, actually, things might get more complicated. You will notice more hires in the team. Someone is named the business analysis, is involved in the analysis here. Another guy, sorry, this is a business guy, like working with the business guys. System analysts doing the analysis here. And architects are also working on the high-level designs. And tech leads at devs. So big projects would require a lot of people to be doing these different steps. That's all. In case you would like to read, I found the book C++ How to Program is a very nice book. However, I'm doing a very intensive coverage for the topic. You will almost not find something extra in the book, so reading is more of optional if you get lost. One of the interesting things in books, they have typically some true-false questions after their chapters. I would say they are nice to try. There is a nice book called Head First Object-Oriented Design. I would suggest for you to give a read for this book after the course. After the course, you would find reading the book much easier for you. A good software engineer reads a lot of very deep books in software engineering. In future, I would like you to explore this link and also this nice book and start to learn. It takes time to educate yourself. Coding guidelines. This is some coding guidelines, like one from Google and another guy. In industry, we write following some guidelines so that our code has good names and so on. So also you feel free to familiarize yourself with that. That's it.